Still in section 3.3 discussing differentiation rules, and we're now into a couple of the more complicated rules. The first one that we're going to talk about is called the product rule. Okay, so now what that means is if I have two functions that are multiplied together. So now I have the derivative with respect to x of u times v. Okay, this is not the derivative of u times the derivative of v. That's very important. When I had u plus v, it was just a derivative of u plus a derivative of v. Okay, but when I have the product rule, what I have to do is, and the way I usually say this when I memorize it, is the derivative with respect to x of u times v is, so, or the first times the second, is the first times the derivative of the second plus the second times the derivative of the first. So it's u times dv dx plus v times du dx. Again, I'll say the derivative with respect to x of two functions multiplied is the first times the derivative of the second plus the second times the derivative of the first. It's usually how I memorize it. Okay, so, and by the way, I go through and prove this. I'm not asking you to be able to regurgitate this. It's actually, I want you to kind of, rather than just push the I believe button, that is the rule, I'm trying to show you that we actually have to use the definition of the derivative to prove that this is true for multiplying any two functions. So I go through this. It's a little bit intensive algebraically. Not too bad. If you take your time when you write this out, you can see how it works. But I would not expect you to think of this proof on your own, of course. Okay? So let's do an example. Okay, in this example, example 33, we want to find the derivative of y equals the quantity x squared plus 1 times the quantity x cubed plus 3. So the first thing I'm going to do is find the derivative of this guy by applying the product rule. So this is my first function, x squared plus 1. My second function is x cubed plus 3. These are multiplied together, so I must use the product rule, right? This is u times v. Okay? And the way I said to memorize this is the first times the derivative of the second plus the second times the derivative of the first. So the first, x squared plus 1, times the derivative of the second, which is the derivative of x cubed plus 3. So once I take the derivative of x cubed plus 3, I just use the power rule on x cubed, which gives me 3x squared. The derivative constant is 0. So it's the first times the derivative of the second, plus the second, x cubed plus 3, times the derivative of the first. I wrote them in opposite order here, but you know, it doesn't matter which way you write them. So the second times the derivative of the first, so that would be x cubed plus 3 is the second, times the derivative of x squared plus 1. So I use the power rule on x squared to give me 2x, and the derivative of 1 is 0. So 2x times x cubed plus 3. So when you're writing out the derivatives, you could leave it like this, but this could be simplified, right? I could now multiply through here, so I could distribute, and I get 3x to the fourth plus 3x squared. When I distribute here, over here I get 2x to the fourth plus 6x, right? When I distribute the 2x through. So then when I combine the like terms, I get 3x to the fourth plus 2x to the fourth is 5x to the fourth plus 3x squared plus 6x. Okay, so that's in its most simplified form. Now, again, because I've proven the product rule to you up above, but rather than just totally push the I believe button again, I want you to see that I could also take the derivative of this. This one is not a real complicated product of two functions because I could actually multiply this out pretty easily by just foiling here. So x squared times x cubed is x to the fifth, right? We add exponents. Then I have x cubed times 1 is x cubed. Then I have 3 times x squared, so that's 3x squared. And then I have 3 times 1 is 3. So I just foiled that, all right? And then I could just take the derivative straight out of that by using the sum rule, right? The derivative of a sum of functions is take the derivative of each piece. So the derivative of x to the fifth, power rule is 5x to the fourth. The derivative of x cubed, the power rule is 3x squared. The derivative of 3x squared, the combination of the constant rule and the power rule, but just bring the 2 down. You get 6 times x to the 2 minus 1, 6x. And the derivative of constant is 0, and you notice these are the same. So this is just an example of sometimes we can multiply the functions out, simplify them, and just take the derivative with the other rules we had. Later on, you'll see that there'll be more complicated functions that are multiplied where there's nothing you can do. You have to use the product rule.